to element mode and select the 2 original spheres. Max actually remembers what those elements are. And the same is true of the teapot. The spout, the lid, the body and the handle are all treated as elements. So I'll turn on object elements, and now you can see that the actual teapot's been broken down into its elements. You can see you've got the body, the lid, the spout, you've got the body here again, the lid, the spout, and a couple of handles over here. So that's pretty cool. You can actually model an object, attach it all together, hand it to particle flow, and it can break it back up again using this random function, which is pretty useful. So let's move on from there and have a look at the hierarchy of objects. Now I'm just going to turn off object elements there. Click here, pick on the base object in the hierarchy. I'm going to turn on scale and actually scale them down a little bit. Get rid of the random variation. There we go, scale them back up a bit. Turn on shaded mode. Now you can see as I scrub again, the teapots appear on the object. I'll just scrub back again, and one of the things you'll notice is that it's taking the hierarchy as it's defined here and it's reproducing it exactly on the teapot. But you can also see that we're getting a snapshot basically of the mesh at frame 0. Frame 0 is nearly always in most systems treated as the rest frame for animation, and it's actually doing the same here. So there are a couple of things that we can have a look at. The first is objects and children. Now what that will actually do is it'll break up the hierarchy and it'll take the objects in the hierarchy and use them on individual particles. So I'll just scrub the timeline again, turn on objects and children, and you can see now it's actually done exactly what I've just said. You've got a teapot here, pyramid here, toruses and so forth. So you can see again, by creating hierarchies of objects, you can actually hand the first object to particle flow, and using object and children you can actually have particle flow randomly break these up. As with any of these random functions, as with most other operators, you can go down to the uniqueness value and put in a different seed, and it should actually, if I tell it to update the particle shape. Okay, in this case it's not a random value, it seems to be a fixed function. So it's actually one of the few cases where what appears to be a random function actually isn't. It's follows some sort of predefined pattern. My guess would be it's following an ID pattern. And what I mean by that is the teapot is treated as object 1, torus as object 2, and pyramid as object 3. And it's assigned the teapot to particle 1, torus to particle 2, pyramid to particle 3, teapot to particle 4, torus to particle 5, pyramid to particle 6, and so on. It just repeats. So I'm guessing that's actually what happens in that instance. It's not using a random function. Now, if I turn off object and children, the other thing that I just mentioned is that it's a frozen mesh. It's not animating. And one of the things that many people obviously want to do with hierarchies and fixed meshes is they obviously want those to animate. A typical thing would be a bird flying through the sky, or a bee, insects, or beetles, or maybe little robots walking around. So using any of these options here, you can actually have any one of these objects animated, and it's just a case of actually getting that animation to appear in particle flow. Now for that you've got two options. Well, you've got two options of how you actually handle the animation data and what you can do with it. The first option is, do you want to acquire the current shape of the actual mesh when the particle is created? So you can see in this hierarchy it wobbles back and forth, and you can see we've got static meshes here. So what I'm going to do is I'm going to tell it to acquire the current shape. So what particle flow will do is, on the creation frame of the particle, it'll look at the current shape of the hierarchy and it'll snapshot that and use that as the particle shape. So we're not going to end up with animated meshes as particles, but we are going to end up with different meshes for each particle, as long, of course, as, you know, if the hierarchy animates. If the hierarchy